Hello students, today we learn about the chain drives. In today's discussion, we see the topics as introduction of chain drives, applications of chain drives, advantages and disadvantages of chain drives, then some technical terms, that is pitch of chain, then pitch circle diameter of chain sprocket, and the relation between pitch of chain and pitch circle diameter of chain sprocket. So today we learn these topics. We start with introduction of chain drives. In belt and rope drives, slipping may occur. In order to avoid the slipping, steel chains are used. The chains are made of number of rigid links which are hinged together by pin joints in order to provide the necessary flexibility for wrapping around the driving and driven wheels. This figure 1 shows the small size sprocket and big size sprocket. If we consider the small size sprocket as driven sprocket and if a large size sprocket is driving member, so some chain links are provided on the small size sprockets. So we show some links here, and on that links small size circles are also shown, and that circle is the representation of hinges. Then these wheels have projecting teeth of special profile and fit into the corresponding races in the links of the chain as shown in figure 1. The tooth wheels are known as sprocket wheels or simply sprockets. These tooth wheels is similar like a spur gear. If we see the application of chain drive, many applications are there. The chains are mostly used to transmit the motion and power from one shaft to another. When the center distance between their shafts is short, it is used in first in bicycles, second in agricultural machineries, third in motorcycles, fourth application is conveyors, fifth is rolling mills, sixth is road rollers. The chain may also be used for long center distance of up to 8 meters. The chains are used for velocities up to 25 meters per second and for power up to 110 kilowatts. If we see the advantages of chain drive, if we compare these advantages with belt or rope drives, many advantages are there. First is, as no slip takes place during chain drive, hence perfect velocity ratio is obtained. Second, since the chain are made of metal, therefore they occupy less space in width than a belt or rope drive. Third is, it may be used for both long as well as short distances, as we already discussed at the time of applications. Fourth, it gives a high transmission efficiency, that is up to 98%. So this is very high percentage. Fifth, it gives less load on the shafts. Sixth advantage, it has the ability to transmit motion to several shafts by one chain only. That is, if we use only one chain, then at multi point we transmit that rotation. Seventh, it transmits more power than belts. Eighth, it permits high speed ratio of 8 to 10 in one step. Ninth advantage, it can be operated under adverse temperature and atmospheric conditions, that is at variety of temperature or in large range of temperature it can be used. Disadvantages of chain drives over belt or rope drives. If we see the disadvantage, first is the production cost of chains is relatively high. If we see the second disadvantage, the chain drive needs accurate mounting and careful maintenance, particularly lubrication and slack adjustment. Third disadvantage is that the chain drive has velocity fluctuations, especially when unduly stretched. Now we discuss about some technical terms that is used in chain drives. This figure second sees the term that is chain drive arrangement. This green color part is nothing but sprocket. This circle is called as chain rollers, which is represented with red color. At the center of these chain rollers, we see some symbols are given, that is A symbol, then B is the center, C, D. These are the center of these chain rollers. Then this chain roller, if we see at the center, this center point is nothing but hinge centers. This is also called as hinge center as shown in diagram. In diagram some terms are also shown, that is capital D is the pitch circle diameter, then D1 is the chain roller diameter. If we consider A and B is the distance between two corresponding hinges in that links, then distance A to B is nothing but pitch distance. If we find out the angle, that is AOB is angle theta, and the center of this sprocket is given by using the symbol O. Now if we see the pitch of chain, that is definition, it is the distance between the hinge center of a link and the corresponding hinge center of the adjacent link as shown in figure second. It is usually denoted by P. In this figure, this distance A to B is the pitch distance. Second, pitch circle diameter of chain sprocket. It is the diameter of the circle on which the hinge centers of the chain lie. When the chain is wrapped round a sprocket as shown in figure second, the points A, B, C and D are the hinge centers of the chain, and the circle drawn through these centers is called pitch circle, and its diameter, which is represented with capital D letter, is known as pitch circle diameter. If we find out the relation between pitch and pitch circle diameter, since the links of the chain are rigid, therefore pitch of the chain does not lie on the arc of the pitch circle. The pitch length becomes a chord, so which is represented in this figure number second, that is distance A to B straight line. Consider one pitch length AB of the chain subtending an angle theta at the center of the sprocket. Let capital D is the diameter of the pitch circle, capital T letter is the number of teeth on the sprocket. If we observe the figure second, we find that pitch of the chain, that is P, is equal to AB. By using trigonometric ratios in triangle AOB, so 2 times AO into sine theta by 2, which is equal to 2 into, we substitute AO distance. This AO is nothing but radius, which is equal to D by 2. So 2 into D by 2 into sine of theta by 2, which is equal to, this 2 gets cancelled. Therefore D into sine theta by 2. We know that if we want to calculate the angle theta, then total angle of circle is 360 degree divided by number of teeth on the sprocket, that is T. We substitute this term in place of theta. Therefore P is equal to D into sine into bracket 360 degree divided by 2 times T bracket complete. If we calculate this, then P is equal to T into sine 180 degree divided by T. And if we write the relation for pitch circle diameter D, therefore D is equal to P upon sine of 180 upon T. But we know that in trigonometric relations 1 upon sine is equal to cosec. Therefore D is equal to P into cosec 180 degree divided by T. The sprocket outside diameter, that is DO, for satisfactory operation is given by, this is empirical equation. This empirical equation is find out by using the practical experience. So DO is equal to pitch circle diameter T plus 0.8 into diameter of chain roller, which is represented with D1. Okay, therefore DO is equal to D plus 0.8 into D1. This is the relation between pitch and pitch circle diameters. So today we learn about the introduction of chain drive, applications, advantages, disadvantages, relation between pitch of chain and pitch circle diameter of chain sprocket, and here we stop. Thank you.